So this is the subject Introduction to Computer Systems, and in today's class we'll discuss about the advantages and disadvantages of computer, the similarities and differences between the human and the computer. Both you have similarities also. Okay. If I ask you any question, you will not answer. Even if I ask the computer, it will not answer. So you have similarities and you have differences also. You have six senses. It doesn't have any sense. Okay, right. And then you discuss about the components of a computer system. Okay, so this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So I would never ever forget to thank God. No matter whatever you are in life, no matter how much money you get, no matter what position you are in your life, don't ever forget to thank God. Okay, as for me, I thank God for giving me this golden opportunity to deliver this useful session, to share my knowledge among my fellow national international participants, students and young researchers. So topics are pretty much similar. We are going to discuss about the advantages and disadvantages of computer. Then we discuss about the similarities and differences between the human and the computer. We discuss overall what do you mean by a computer system and what are the components of a computer system. These are the advantages of computers. Okay, you can discuss in terms of speed, accuracy, efficiency, storage capability, versatility and so on. Okay, when you take in the case of speed, you know very well a computer is able to process millions or maybe billions of instructions. Okay, so it is capable of performing these instructions very fast within a second. For example, you type, it appears on the screen. For example, you run a C++ code, immediately it will produce an output. For example, you press Control and then P, immediately it will print. It happens within a second. Okay, so speed of the computers are measured in milliseconds. Milliseconds means 10 power minus 3. Okay, or maybe microseconds, 10 power minus 6, or maybe nanoseconds, 10 power minus 9. So you can call computers to be not fast machines, super fast machines. It is capable of processing millions or maybe billions of instructions per second, and even complex machines also. I am talking about lower end systems. Higher end systems, very fast. Okay, and then accuracy. For example, if I tell you do your open-ended project work within tomorrow, you will somehow do something and finish. That's it. But computer, you cannot do that. Computer, it will do accurately. Okay, so computers are very accurate. Without any error, without any problem, it will produce the output. Okay, for example, you press Control plus P. Okay, so it will not save the document. It will print the document. So what instruction you have given, it will process. Okay, so they do not make mistakes, and of course they perform every calculation with the same accuracy. For example, it will not say, doctor, I have worked for 8 hours. Doctor, I want to go to the hotel for working. Doctor, I want to print this one. Doctor, I want to meet the dean. It will not say. So it will, no matter whatever instructions you give, it will produce the output. It will not say, my back is paining. I work for 8 hours. It will not say. Okay. And then you have efficiency. Even if you change the motherboard, if you change the central processing unit also, you can still make the computer work. So after 5 years, it will not say, I've grown too old. I cannot manage. I cannot manage these tasks. It will not say. Okay. So the computers, even it can perform repeated tasks. Okay. If I give you the same work, uh, hold this chair, keep it down. Take this chair, keep it down. If I say 10 times, you will say, what is this nonsense? Why is this doctor telling again and again? If I tell him, go and bring the projector and come, one time, two time, he will listen. 10 times if I say immediately, doctor, I am going to the kitchen, I am going to Ashwana, bye bye, he will say. Okay. So even repeated tasks also computer is capable of doing without any exhaustion. Okay, exhaustion, I hope you know the meaning of exhaustion. Then you have the storage capability. It is capable of storing large amount of data in the storage devices. Okay, and these devices occupy very less space, and of course it can process millions of instructions per second. Okay, so the storage devices include maybe floppy disks, but now not many are using floppy disk. Okay, we have tapes, hard disk, of course you use hard disk, you use CDs. Okay, where you try to store the data. So maybe in the computer, if you can see gigabyte, yes, 100 gigabyte, 250 gigabyte. Ikke use elic, ikke use elic gigabyte you have. But hard disk, if you can see, terabyte, 1 terabyte, 10 terabyte, 100 terabyte. Okay, so this is how you store the data, and anytime you can retrieve it. Anytime you can take the data out of the thing, out of the hard disk, out of the floppy disk, and you can reuse it. Okay, not like CD, not like CD. For example, you store it and you cannot cut it and paste it somewhere. Okay, earlier CDs it will be like this, but now we have DVDs, rewritable. Yes, rewritable. Hard disk you have. Okay, computer also you have for storing the purpose. Versatility. Computers are very versatile. Okay, so they are capable of not only performing complex mathematical tasks but also non-numerical operations. For example, if I have to book the flight ticket, if I have to book Afrosia, or maybe Airways, I have to book. Okay, electricity bills I have to pay, databases I have to manage, everything I can do that. So the computer is like a hero doing all the tasks. Okay, right? So this is how you use the computer, but there are certain disadvantages also, limitations also. Okay, computer cannot think because it doesn't have any brain. Human, they think, they have brain. We have brain, but we use very less. Computer doesn't have brain. That is the reason whatever you say it is doing. Okay, so it can execute only those jobs that can be expressed as a finite set of instructions. Okay, and computers does not learn from previous experiences, or it can come to a conclusion. Only thing you have to feed. If step 1, then you proceed to step 2. We have to feed it. It doesn't do, it doesn't have previous experiences. Okay, for example, if daily we have the class at 8 o'clock. Okay, daily if we have the class at 8 o'clock seconds, and they are not opening this door for 10 minutes or 15 minutes, what you will do? After 5 days you will come automatically at 8:15. You will not come at 8 o'clock. Yes, this is learning from the previous experiences. Our Ashona is closed for the past 3 days. For the 4th day, you will not go to Ashona and see whether Ashona is open or not. No, we know it is closed, so we see the alternatives. This is learning from the previous experiences. Okay, and there are similarities as well as differences between human and computer. Computer is a very effective and efficient machine which performs several activities within few minutes. Okay, computers are faster, more accurate, but definitely you cannot compare a computer and a human being. A computer is a dumb box. Human being is capable of doing many things. You can eat your ash, see your mobile, chat with your friend, do multiple tasks, do your assignment. You can do many more things. Computer cannot do it. Right. So there are some similarities between the human and the computer. Human has ears, nose, eyes, and so on. Computers also have the same thing. Similarly, like keyboard, microphone, scanner, touch screen to get the information. Yes, we remember things. Computer cannot remember, but it will store. It will store and it will retrieve it for future use. We collect certain information as required. Computer also retrieves information at times. We express ourselves by speech, by writing. Computer through the screen, through the A4 sheet printout, through the A3 sheet printout, it will give the output. When we watch, hear, learn certain things, or you can also analyze. Computer, it has its own software. Okay, for example, you take in the case of mobile, you have applications. So it can analyze information and you can draw conclusions out of it. For example, to convert MS Word to PDF, you have an application. Yes. So for each and everything, computer has an application. Similarly for us also. If I have to go to the university, handle class for you, I cannot wear a shirt and a shorts and come. Immediately my brain will process, okay, I should wear coat, I should wear suit. Similarly, computer also programs. Okay. The place where we store, analyze, we have the human being. Computer, it is going to have a CPU. CPU is the computer's brain, where it can process all the instructions and analyzes the information. So computer, as I told you, it has floppy disks, hard disks, compact disks to store as well as retrieve information. Computer does not understand emotions. You cry before the computer, computer will not say, "Oh, Papa, keep quiet." It will not say. Okay, right? It cannot read between lines like the human beings. Okay. For example, if I give maybe a test for 15 minutes, finish your test within 15 minutes. Immediately, last 5 minutes, you will somehow manage. But computer cannot manage. Okay, it will process line by line only. Okay, we learn many things unknowingly. Your friend would have told, in near the Sinbad Cafe, Afiona is actually closed. Your friend says that. Okay, but computer cannot say. Okay, so computers can learn everything only knowingly. Only if you feed the instruction, then only it will learn. Otherwise, it will not learn. Right? We learn many things on our own, but computer has to be taught everything. Okay. So this is a computer system where we have a group of integrated parts. Okay. Everything has been designed to achieve a common objective. Okay, which means that you give some certain instructions and computer has to process and it has to produce the output. Okay. For example, if I say to you, okay, tomorrow you have to tell everybody, okay, tomorrow you have to tell everybody to complete the assignment. If I am telling you, okay, somehow he forgot, next day he will say, okay, he will tell me a reason. Doctor, I told everybody this guy is sleeping, this guy is not responding, this guy didn't pick my phone. You will say like this, okay. But computer, it cannot say. Like computer has a lot of devices, a lot of components that are associated. Everybody or every component works together for achieving a common objective. That's what you call a teamwork within a system. So a system is made up of not only one element or part, but more than one element or more parts. So every element will be performing a specific function and all elements are logically related. For example, you take in the case of the components like we operators, logical operators, relational operators, and, or, not, bitwise operators, addition, subtraction, multiplication, division. Okay, so every arithmetic operators are being related and in order to achieve the common goal. Okay. So computer, we have three main parts. One is CPU, central processing unit. Second one, input as well as output devices. What is input device?
Mouse, keyboard,
Output device? Monitor, printout, scanner. Okay. So every unit will be performing a specific tasks, and underline this one, none of them can function independently on their own. You have to tell do this and it will do. Okay. If I press Ctrl plus P, it will print. If I type the screen, it will show. Okay. So they are logically related and controlled to achieve a specific goal. Okay. So these components are combined together or may be integrated so as to form a complete computer system. As I told you, central processing unit, input as well as output unit, and then storage devices. So this is the schematic diagram of the central processing unit. We have the input unit, we have memory unit, okay, MU, ALU, what is ALU? Arithmetic and logic unit, CU, control unit. So everything, memory unit, arithmetic logic unit, control unit, it forms the CPU, central processing unit. So from the input unit to the CPU, CPU to the output. So data flow goes in this fashion, okay, and this is the control flow from the input unit to the CPU, CPU to the output. Right. What is the function of input unit? So they are nothing but devices which are used to feed the programs or maybe data. Not only data, programs also you can feed. Okay. So input unit or maybe input system is going to connect the external environment with the computer system, and it's nothing but the communication, the direct communication between the user and the computer. So we have keyboard, floppy disks, mouse, mic, light pen, joystick for games, magnetic tapes. So they are input devices. So through this, it is being fed to the computer. For example, if I am playing a game called Duck Hunt, if I do like this, immediately the duck will die. You remember the earlier game in the TV? Have you played a game called Duck Hunt? Yes? No? You are 2K kids, huh? You don't know? Duck Hunt. For example, there is one gun-like thing. Okay. So in the TV, if duck will, there will be some grass or maybe trees. The duck will jump like this. Okay. At that time, you have to shoot. So when we give input in the screen, the duck will feed. Okay. So this is how you can use the joystick. Okay. Right. The way in which data is fed to the computer through each of the device is different. Okay. But computer, it can accept only one format of data. Only if it is fed in the specific form, only then it can produce the output. Okay. So you cannot give inputs just the way you want. Computer should understand. You should give the input in such a way that computer should understand. For example, in a C++ program, don't give the format of a PHP or maybe Python program. C++, it only understands in that format. Okay. So the input devices transform the data fed to them into a form which can be accepted by the computer, and these devices are a means of communication and interstation between the users and the computer systems. So the input input unit, it is going to accept the information or data and programs, convert the data into a form which the computer can accept, and processes it, converts this converted data to the computer for further processing. And this is the central processing unit. So it is considered as the brain of the computer system. So in the computer processing unit, CPU, we have CU, control unit, ALU arithmetic logic unit, and primary storage unit. I am talking about this diagram: memory unit, arithmetic logic unit, control unit. Okay, so this is CPU. What is the work of control unit? As the name implies, it is going to control the operations. Okay, so it is going to get the instructions from the programs stored in the primary storage unit. We have primary storage and then secondary storage. So it is going to get the instruction from the programs stored in the primary storage unit. It is going to interpret the instructions, and it is going to direct the other units to execute the instructions. So getting the instructions, telling everybody do this, and process the instructions. Okay, so it is going to manage and coordinate the entire computer system. And then arithmetic logic unit, it performs the calculations, it executes the instructions, and it is the decision maker. Arithmetic logic unit is the decision maker. Okay, so the data is held in the primary storage unit and it is being transferred to the ALU arithmetic logic unit as and when required. So data can be moved from the primary storage unit to the arithmetic logic unit many times, okay, many times before the actual process is completed. So after the completion, the results are sent to the output unit, output storage unit. Okay, for example, in the computer, you try to work on the application and maybe you feel tired, you will save it, it will be there. Day after tomorrow, you open and you get the same output. Computer will not say, no, you sent it 3 days back, we cannot save it. It will not save. Okay, so for retrieving, for future purposes, it is going to store it in the output storage section and the output devices. Then primary storage unit. Primary storage unit you can also call as the main memory. So before the actual processing starts, the data and maybe the instructions are fed to the computer through the input unit, and they are actually stored in the primary storage unit. For example, if you have to, if I have to conduct the test, I have to say, all students, please come in your neat dress. Okay, you have to come at 8 o'clock. I have to give you instructions. Yes, and next one, you have to prepare for your exams. This is the syllabus. These are the materials. I have to give instructions. Only then you will come for the exam. Without anything, you cannot, I cannot expect you for the exam. Okay. So this is how the instructions goes on with the primary storage unit. So the data which is to be output from the computer is also temporarily stored in the primary memory. Okay. It is also the area where intermediate results of calculations are stored. So temporary memory is actually where you can have with the primary memory. So the main memory has the storage section that holds the computer programs during the execution. These are the functions of primary storage unit. So it is going to store data and programs during the actual processing, stores the temporary results of intermediate processing or maybe intermediate calculations, and stores the results of execution, executed results also temporarily. Okay. Then you have output unit. Of course, you know output unit, it is providing the output. So output unit accepts the results produced by the computer. Okay, computer will have the machine language. Yes, so everything, the machine language, it should be converted to the human understandable form. Yes, it will produce the output, but we should understand. Okay, right? So it is converted into human readable form and supplies them to the users. So common output devices, we have printers, plotters, scanners, display screen, magnetic tapes, tape drives, and so on.